Hi and welcome to the first video of the course MCV4U. We're going to go ahead and start with the first section, which is radical expressions and rationalizing denominators. So basically for this whole section, we're going to go over the process of changing radical numbers in the denominator into rational numbers. So what's going to happen is that they're going to give you numbers such as 5 over root 2 or 3 over root 5 minus 2, and they'll expect you to change this into a rational number. So what is a rational number? It is basically a number that is expressed as a fraction which contains integers. So such as we can say 1 over 3 is a rational number, 5 over 6 is a rational number, and negative 7 over 12 is an example of a rational number. So basically it's anything in the form of p over q, where q cannot equal 0, because if it equals to 0 then it's undefined, and p and q are integers. So we're just going to go ahead and start with our first example, which is to simplify 5 over 6 root 5 by rationalizing the denominator. So first thing first, we can start by writing it exactly as it is. And if you look at the question, it wants us to rationalize the denominator. So when you look at the denominator, which is here, we see a radical number, which is root 5. And we want to get rid of that and change it into a rational number. So in order to do that, we times whatever the radical number is, which is root 5 in this case, and we multiply it by the numerator and the denominator. So when we do that, we're going to be ending up with, for the numerator, 5 times root 5 over, for the denominator, anything root times another root is basically the same thing as getting it out of the root. So you're going to end up with 5. And if they're the same numbers, so you can kind of memorize it as root x times root x, you're going to end up with x. So in the denominator, we're going to be ending up with 6 times 5 because we got it out. And if we simplify it, we're going to end up with 5 root 5 over 30. And if you want to go ahead and simplify it further, we can divide these by 5. So 30 divided by 5 is 6, 5 divided by 5 is 1. So we ended up with root 5 over 6. So that's going to be our number. So another example you guys are going to encounter is when the denominator involves two-term expressions. So such as in this one, it's root 6 plus root 3. So basically, if you have a two-term expression such as root a plus root b, then in order to get rid of that, you basically multiply it by its conjugate. So the conjugate of this would be root a minus root b. So in this example, if we apply it to this, we're going to write it as it is. And we're going to multiply it both sides by the conjugate of this. So just changing up the sign, minus root 3. So root 6 minus root 3. So if we start from the top, 3 times root 6 is 3 root 6 minus 3 times root 3 is basically 3 root 3 over. Now let's start with the denominator. So root 6 times root 6, just as we did in the last example, it's just going to come out as 6. And root 6 times root 3 is basically, I'm just going to put it here because at the end it's going to basically cancel out. So negative root 6 times root 3. And if we start with root 3 times root 6, then it's a plus sign. Remember, here was our negative sign, so we're going to do plus root 6 times root 3. And at the end, when we multiply by root 3 times root 3, it's a minus sign, so it's going to be minus 3. And if we look at here, minus root 3 times root 6, and then plus the same thing, it's just basically cancels out. So what we end up with is 3 root 6 minus 3 root 3 over 6 minus 3. But if you want to simplify it further, for here, you can basically take 3 out. So when we take the 3 out, because both of the expressions have the same number, we can end up with root 6 minus root 3, and then basically divide it by 3. We can cancel these out, and you're going to be ended up with root 6 minus root 3. So another type of question you can also see is when they ask you to simplify by rationalizing the numerator, so not the denominator in this case. So in the concept, it's basically the same thing, but let's just start writing by as it is, and then we're going to basically multiply by its conjugate again, but instead of the conjugate of the denominator, we're using the conjugate of the numerator, because that's the part we're trying to get rid of. So we're going to start by saying root 3 plus, so we're changing up the sign, root 7 plus root 3, and then same thing for the numerator. And if we multiply these, so root 7 times root 7, we're going to end up with 7. Root 7 times root 3, we're going to end up with, because these are going to cancel out, I'm going to put a bracket. So root 3 times root 7. And then we'll start by multiplying negative root 3 by root 7. So it's negative root 3 root 7, close the brackets. And the last portion is multiplying negative root 3 by root 3. So it just comes out as negative 3 over. So here we can just say 2 times in bracket root 7 plus root 3. Because in most of the cases, whatever is outside, like this portion, is probably going to be cancelled out by whatever we end up in the denominator. So we can start by cancelling this portion out because it's positive and the negative of the same number. So you can think of it as like 5 minus 5. So we ended up with 7 minus 3 over 2 in brackets root 7 plus root 3. So 7 minus 3 is 4 over 2 root 7 plus root 3. And like I said, these cancel out. So most of the cases, if you see it like this, just leave it as in this form and then you'll see what you get. So our answer is basically 2 over root 7 plus root 3. Remember, this question was asking rationalizing the numerator, so you don't have to deal with, oh, why didn't we rationalize the denominator? So from this point, I'm going to solve more of the complicated questions that you might see, so more of level 4 questions for this section only. So one example is simplifying 3 root 3 minus 2 root 2 over the same thing but the plus sign by rationalizing the denominator. So we can start by literally writing as it is. Okay, so always look for whatever the question is asking you. So it's asking you to rationalize the denominator. So when we're multiplying, because it involves 2 forms, 2 expressions, you're gonna multiply it by its conjugate. But the conjugate you're choosing is the denominator because it wants us to rationalize the denominator. So over here, I'm gonna multiply numerator and the denominator by 3 root 3 minus 2 root 2. And then the same thing for the denominator. So when we do that, so I'm going to first start with the numerator. So multiplying these will give me 3 times 3 first. So it's 9. And then root 3 times root 3. Remember, you can't just multiply this 3 by the root 3 here. They are 2 different expressions. So 3 times 3 is 9. And then root 3 times root 3 just comes out as 3. And then I'm going to multiply this by negative 2 root 2. So I'm going to end up with negative. So 3 times 2 is 6. Root 3 times root 2. Just to simplify it, you can multiplies these inside, so it basically comes up to 3 times 2 in the root, so you're going to end up with root 6. So here I have root 6. Then I'm going to multiply these two, so negative 3 times 2 is 6. Again, in the root it's 2 times 3. I'm going to end up with root 6. And then we're going to multiply these two. So it's negative times negative, which is plus. 2 times 2 is 4. Root 2 times root 2 just comes out as 2. Now we can start with the denominator. So we're going to multiply these two, which is 3 times 3 is 9. Root 3 times root 3, it's the same thing as the above. Just be careful with the signs. And then we're going to multiply here, which is negative 2 times 3 is 6. Root 3 times root 2 is root 6. And then we're going to multiply these two, which is plus 2 times 3 is 6. Root 2 times root 3 is root 6. And then lastly, we're going to multiply these two, which is negative 2 times 2 is 4. Root 2 times root 2 is just going to come out as 2. Okay, so, and then we need to simplify all of this because it's a mess. So 9 times 3 is 27. Minus 6, so basically you can just add them together. So 6 plus 6, you can think of it as that, is 12 root 6. And then 4 times 2 is basically 8, so plus 8. Over, same thing, so 27. But because here the signs are negative and positive, these just cancel out. So we're going to end up with negative 8. To simplify it even further, we're going to say, I'm just going to leave this for now. So I'm going to do 27 plus 8, which is going to come up to 35, minus 12 root 6, over 27 minus 8 comes up to 19. So I'll be solving the last example that I think you guys need to know in terms of the type of questions. Is when they just give you variables such as x plus h. But it's the same idea. So in this case, it wants us to simplify this by rationalizing the numerator. So always check what they're asking for. So I'm going to start by writing as it is. So we have root x plus h minus x over x. So because it wants us to rationalize the numerator, when I look at it, I have two expressions. So what does that mean? It means we need to use its conjugate. So we're going to times it by the conjugate of this. So it's going to be root x plus h plus x. We just change up the sign. So same thing here. So when we do that, I'm going to start by multiplying the numerator. So multiplying these two numbers, these two expressions, it's just going to go out of the root. So we're going to end up with x plus h. If you want to make it more simple in terms of just seeing the expressions and simplifying, you can put it in brackets. And I'm going to simplify this again by plus x. So plus x just goes outside because it's not in the root, and then I'm going to end up with root x plus h. Same thing here. This is negative x times root, so I'm going to end up with negative x root x plus h, and then I'm going to multiply negative x here with plus x, so I'm going to end up with negative x squared. So that's my numerator. So I'm going to start with the denominator now. So x times this root x plus h is just x root x plus h. And then I'm going to multiply x by plus x. So I'm going to end up with plus x squared. So now we need to simplify these. So I have here negative sign and a positive sign of the same thing. So I can just cancel these out. So I'm going to end up with x plus h minus x squared, and over I'm gonna have x root x plus h plus x squared. So if you want to simplify this a little bit more, you're going to end up with x plus h minus x squared, because we cannot simplify the numerator because of the h. We cannot take x out. But over here, this expression has x, this expression has x, so I can take it out and leave it as root x plus h plus x. And that would be my answer.